So we're going to talk about enzymes and how they apply to our body. So enzymes, this is what your notes outline is going to look like. You have this chart. What are enzymes? How do they work? What are their parts? What factors affect them? And how does this look on a graph? So enzymes, what are they? So they're a protein. So remember that they're a protein that acts as a biological catalyst, meaning it speeds up chemical reactions. So it's a protein and it speeds up chemical reactions. Remember that. That's very key. So the biomolecule again is protein. It speeds up chemical reactions, also known as a catalyst. So we'll talk about this graph in a minute, but you'll see that the enzymes will either join together or the enzymes will break apart. So here's an example of synthesis where they come together, and then digestion where it breaks up the molecules. So remember, enzymes, they speed up reactions and they're a protein. So act like it is Pac-Man coming in and taking in its food and then spitting it back out. So how do they work? They speed up chemical reactions by lowering the amount of activation energy. So activation energy is the amount of energy needed to start a chemical reaction. So if you look at the frogs, it's with no enzymes, it takes a lot more work to make like the product, but with enzyme catalyzed or having enzyme catalysts, it doesn't have as much work to create product. So just think of it as helping your body not work as hard. What factors affect them? So the best conditions for an enzyme is going to be optimum. Inhibitor, it prevents, so optimum, it's going to have an optimum pH and an optimum temperature. So temperature really affects the enzyme activity. The more the temperature, it is a factor that affects an enzyme, and the pH is a factor that affects the enzyme. So which of the enzymes above would work best in the stomach? I already clicked it, but pepsin because the pH is lower. What is the optimum pH for salivary amylase? So here's salivary amylase, and the pH that's optimum is 6. So inhibitor, it prevents substrate from attaching. So here's the substrate attaching. So an inhibitor will prevent from that happening. So it kind of comes in and sneaks in and attaches itself without the substrate being able to attach. It's kind of like jumping in a line so your best friend can't get lunch before you. Denaturation, it changes an enzyme's shape that prevents it from attaching to a substrate. So like here's a normal protein, it's denatured so it doesn't look normal and the enzyme can't attach to the substrate that it's meant for. Here's another example. So what are their parts? The enzyme, the protein that speeds up a chemical reaction. The substrate is the substance that is broken down or put together by the enzyme. So the product is going to be the substance that's produced during the reaction, and the active site is the groove in the enzyme that the substrate binds to. So here you're going to label A through D using the definitions we just went over. Here's a substrate. Here's the active site. This is where it connects to it. And the purple guy is the enzyme. It stays the same throughout the reaction. It's usually the largest that is the enzyme. And then you have the products. Products are going to be the substance that's produced. So you have substrate, it comes in, attaches to the enzyme at the active site. The active site has to be specific for that substrate and the enzyme. it attaches, and then it creates products. So how does this work on a graph? You have energy and reaction. So without an enzyme, it takes a lot more energy for your body to break down. With an enzyme, it has lower activation energy. And that's it. If you have any questions, feel free to email me or Remind 101 me.